Hello again. So we're going to look at expanding double brackets today. If you remember the last lesson, the word expand or multiply out just means to get rid of the brackets. We're going to start with a visual representation of this. So we're going to look first of all at finding the area of a rectangle with the length a plus 3 and the width a plus 5. So I'll just draw that. So here we are. I have drawn the a plus 3 as the length and the a plus 5 as the width. And now we need to find the area of this rectangle. If we start with the top section, we have got a times a, which is just a squared. Let's look now at this section. We have now got a multiplied by 3, which is just 3a. Let's look at this lower left section. We have now got 5 times a, which is just 5a. And the last one that's remaining here is just 3 times 5, which is 15. So the total area of this rectangle is just all of those added together. So we have got a squared. We have also got two like terms. We have 3a plus 5a. Well, 5 plus 3 is 8. That becomes plus 8a. And finally, we have got 15 at the end, plus 15. So that is the area of our rectangle. So now we're going to look at the same question written differently. Multiply out and simplify. A plus 3, well, there's the a plus 3. Multiply by, all multiplied by a plus 5. There's the a plus 5. And that's exactly what you've just done. You have basically multiplied a plus 3 by a plus 5. I want to look at a fast way of doing this, a way of achieving this without having to think visually or draw this out. We're going to use a method called FOIL. And what that means is we're going to multiply out the first in the brackets, then we're going to multiply out the outsides in the brackets, then we're going to multiply out the insides in the brackets, and finally we'll multiply out the lasts in the brackets. So here goes, multiplying out the firsts. A times a is just a squared. Multiplying out the outsides of the brackets. A multiplied by 5 is just 5a. Multiplying the insides, 3 times a is just 3a. And finally, multiplying out the lasts, 3 times 5 is just 15. Notice everything was positive in this case because we've got a positive times a positive, another positive times another positive, and so on. You can see now that this looks exactly the same as what is in the rectangle. So we've just got to neaten this up. This is the simplified part. We bring together any terms that are the same. So we're collecting like terms. Those two are like terms. A squared, there's no other a squareds. That remains on its own. 5a plus 3a is plus 8a. And that's the bit we brought together. And there's no other numbers on their own. So that's just plus 15. And that is our answer. Now look at that. That is exactly the same as what we had here. Let's have a go at a few examples. Okay, so same thing again. We're going to multiply out and simplify, remembering FOIL. We're going to multiply out the firsts. So we have a squared. We're going to multiply out the outsides. So we have plus 7a. Insides plus 3a, and lasts plus 21. We're going to collect the like terms. So we are left with a squared plus 10a plus 21. Let's look at this next one. Multiplying the firsts. They're both positives, so it's positive x squared. Multiplying the outsides, positive x multiplied by a negative 4. Positive multiplied by a negative is a negative. X times 4 is just 4x. Insides, both positive. 5 times x, 5x. Lasts, positive times a negative is a negative, and 5 times 4 is just 20. Collect the like terms. X are the like terms. Notice x squared is not the same as x because x is to the power of 1, x squared is to the power of 2. So we are left with x squared minus 4 plus 5x is 1x. We don't write the 1, it's just plus x minus 20. And that is it. Looking at question 3, we multiply the p by the q, we end up with pq. We multiply the p by the minus 6, we get minus 6p. Multiply minus 2 by q, that is minus 2q. And finally, minus 2 times a minus 6 is plus 12. As you can see in this example, there are no like terms. So that is your final answer. You don't need to do any more than that. Notice now I've changed it from multiply to expand. It's exactly the same thing. We're going to expand and simplify. These look a little bit different. So we've now got extra values in here. So 2x and 3x rather than just x, but the principle is the same. First, positive and a positive is a positive. 2 times 3 is 6. X times x, x squared. Outsides, positive, positive is a positive. 2 times 4 is 8. X on its own. There we go. Insides, positive and a positive gives you a positive. 3 times 3 is 9, and we're left with the x. Finally, positive 3 times a positive 4 is just a positive 12. Bring this together, they're the like terms. So that equals 6x squared plus 17x plus 12. Okay, 5 times 2 is 10. A times A is A squared. Minus times a positive is a minus. 3 times 5 is 15. That's 15A. Minus times a positive is a minus. 2 times 4 is 8. That's 8A. Minus times a minus is a positive. And 3 times 4 is 12. There are the like terms. Let's collect those. So we are left with 10A squared minus 23a plus 12. This last one looks more challenging, but to be honest, it's exactly the same. The square just means multiply by itself. So here goes. I will rewrite that so we get rid of the squared and we just show it multiplied by itself. Now we just expand those brackets. X squared minus 4x plus 16. Again, like terms. So that gives us x squared minus 8x plus 16. So taking this a step further, slightly more complicated, but the principles are exactly the same. Last three questions, expand and simplify. Let's just go through it, remembering FOIL. Notice the x is in a different place here. Doesn't matter though. So firsts, 3x, outsides, minus 9, insides, plus 2x squared, lasts, minus 6x. Let's look at the like terms. So we have got 3x and we have got a minus 6x. So to write this out, we tend to write this in the form ax squared plus bx plus c. So what I mean by this is we put them in order of powers. So x squared before x to the power of 1 before no power at all. So here we go. 2x squared. Now we have got 3x minus 6x, which is minus 3x, and then we're left with minus 9. That's it. This one, if you look at it, you've got two double brackets. So let's rewrite that one. I'm going to just do it a fraction up here. A minus 2 bracket a minus 2 minus a plus 3, a plus 3. So a times a squared, minus 2a plus 4. Remember, this is the key component here. That is a negative 1 here. So what I'm going to do is I'm going to leave the negative 1. So I'm going to leave minus 1, and I'm going to put the answer to this in a bracket. So a times a squared, plus 3a, plus 3a, plus the 9, close that bracket. Now the reason for doing that is I need to multiply out the minus 1 with all of that. So I'm going to simplify this over here. I have now got a squared minus 4a plus 4. Minus 1 times a squared is minus a squared. Minus 1 times 3a is minus 3a. Minus 1 times 3a is also minus 3a. And minus 1 times positive 9 is minus 9. Now we can collect the like terms and simplify this. So that is equal to a squared minus a squared. Well, they just cancel. Minus 4a, minus 3, minus 3. So minus 4, minus 3 is minus 7, minus another 3 is minus 10. So that is minus 10a. And finally, plus 4 minus 9 is minus 5. So we are left with minus 10a minus 5. Again, quite complicated, but can be made very straightforward if you remember that this negative 1 is multiplying by all of this here. Finally, we're going to find the area of a rectangle with length a plus 5 and width a minus 7. So if you see that, you just got to create your own brackets. We have a plus 5 multiplied by a minus 7. And now we can use FOIL again as we did before. So firsts, a squared, outsides, minus 7a, insides, plus 5a, lasts, minus 35. Let's bring these together. That is equal to a squared. Well, minus 7 plus 5 is minus 2. That's minus 2a, and then minus 35. And that is expanding double brackets. So the key thing is, remember FOIL. Remember F is firsts, O is outsides, I is insides, L is lasts, and all you're doing is multiplying each component.